in the types of matrix. Okay, types of matrices. So the first type, you need to know all these types. Okay, after
Mm-hmm.
this will seems like you are learning theory, but you need to know this theory. Okay, because in question directly it will be mentioned that there is a column matrix. Okay, there is a row matrix, there is a square matrix. So this terminology should be clear to you. So the
Okay.
type is column matrix. So column matrix, basically as the name, column, there will be just one column. Whatever be the number of row, the number of column will be one. Okay.
Mm-hmm.
So we can write it, we can write it like this. Whatever be the number of row, the number of column has to be one. Okay. So if
Uh-huh. Yeah.
in just, this is one of the example of column matrix. Now if I
Yeah.
am writing, suppose we are having 2 rows, 3 rows, 4 rows, 5 rows, okay, but the column will be maintaining one. Okay, the column we will be maintaining one. The number of rows can be, suppose we are having 2, 4. This is also one of the example of column matrix. Got it?
Okay. Yes, ma'am.
Similarly, row matrix. Okay, in row matrix, the number of row has to be one. Whatever be the number of column, the row number of row will be one. Okay, so
Mm-hmm.
basically it
Oh.
look like this. Okay, you can have your A, B, C, D like this. You can have your just A, B like this, A, B, C like this. So you can see the number of column. Okay, this A, then B, then C, then D. We will be counting it as a 4 columns, right, Ibrahim?
Yes, ma'am.
But the row is one. Okay, 1/4 matrix we are having. Next one is, we are having here the number of row is one, but the number of columns are two. Okay, so 1/2 matrix. So how, as the name says, row matrix means number of row will be one, column matrix means number of column has to be one and only one.
Mm-hmm.
Now square
Yes,
matrix,
ma'am.
have already this square, this is not a new term to you. You know the about the shape is square. Square is such a
Yes, ma'am.
where the length, breadth, everything is same. Okay, here also we will be having the same. Square matrix means number of row, number of column, both are same. That's called square matrix. You can understand as well that of course when the number of row and number of column are same, then only it will take the shape of a square. Are
Of
you?
square. Yes, ma'am.
Okay, so yeah, you can call it, here we are having 2/2. Okay, we can,
Mm-hmm.
in few examples it will be given that there is a square matrix m by m or maybe n by n. So we, okay, we are clear that number of row, number of column, both will be same. That's called a square matrix. Got it?
Yes, ma'am.
So far we have taken 3 types. Okay, row matrix, column matrix, square matrix. Now the
Square
next one
matrix.
is diagonal matrix. Diagonal matrix. So the diagonal matrix here, all the, just a second. Yeah, all the non-diagonal element, any square, when we are talking about diagonal matrix, we will be, okay, we will be clear that we are having a square matrix, then only we can talk about diagonal matrix. Okay,
Okay.
if your matrix look like this, suppose you are having, suppose 2 1 3 5 8 2. Okay, this is, what is the order of this matrix, Ibrahim?
How many rows are there? One, two.
Yeah,
Row by column and 1, 2, 3. 2 by 3.
2/3 matrix we are having. Okay,
Yeah.
here if I will ask you, Ibrahim, what are the diagonal elements, will you be able to say clearly that
No,
what are diagonal element? No, but when
no,
we
we
are,
can't say. We can't
okay,
say.
square matrix 2 1 3, okay, 5 1 4, 8 7 9, here you will be able to say that this is the diagonal of this square. Yes or no?
Yes.
Okay, so when we are talking about diagonal matrix, we will be saying that any square matrix, okay, is a diagonal when the non-diagonal elements are zero. Okay,
Mm-hmm.
non-diagonal element are zero. So basically wherever I and j will be same. Let me write the structure of the matrix. Suppose we are having 3/3 matrix. Okay, so we'll be having a11, a12, a13. right, Ibrahim?
Yeah.
Okay, A21, A22, A23,
8 2 3. Yeah.
A31, A32, A33. This is
Yeah.
3
Correct.
square matrix. Here, wherever I and j are same, 1 1, 2 2, 3
And
3.
3 3. Yeah.
These are our diagonal element. So wherever I and j are equal with each other, these are diagonal element. Wherever I and j are not equal, those
Mm-hmm.
elements are zero. Aij is zero where I and j are not same. That's the definition of diagonal matrix. Is it making sense?
Yes, ma'am. Yes.
Okay, so here 0, here 0, here 0, here 0, 0,
And 1
0.
3 and 2 3.
Okay,
Okay.
here 0, here 0, and yeah, here also 0. Got it?
Yes, ma'am.
So except this diagonal element, everything is 0. That's called diagonal matrix. Here in your NCRT, always when even if it's diagonal matrix, this is how the matrix will be given. But when you will be doing questions from here and there, like from competitive exam, your diagonal matrix can look like this diagonal, and it will be given as 1 2 3. So you need to understand everything is 0. Here, this is A11, this is A22, and this is A33. And you have to
Uh-huh.
frame the matrix by yourself. Getting it?
Mm-hmm. Yes,
Okay.
ma'am.
If it is given that diagonal 2, 3, okay, not comma, just 2, 3, like this. So you need to understand that you have to frame the matrix, diagonal matrix by yourself.
Yeah.
And this is from here only you are you getting the idea that this is A11, this is A22, and this is 2 by 2
Yes.
square matrix we are having, right?
Mm-hmm. Yes,
But
ma'am. Yes.
okay, so this is how
Yeah.
the example, the question will be given to you. Now, the next type is scalar matrix. Scalar matrix is such a diagonal matrix. Is such a diagonal matrix where all this diagonal element will be same. Okay. Now, one more thing I must add over here in diagonal matrix, that even if the diagonal elements are 0, that is also fine. The condition is the non-diagonal element has to be 0. The
Uh-huh.
non-diagonal elements which are non-diagonal, those elements are 0 or not. If those are 0, now when we are taking the diagonal element, suppose it is given like this. Suppose it is given like this. The diagonal matrix you are having, where 1 0 0, these are the element, this is fine. Okay, diagonal element
Mm-hmm.
can be 0, can be non-zero, that is completely okay. But the condition which is strictly needs to be followed, that is non-diagonal element has to be 0. Got it? Even if I
Yes.
will make all of them 0, that is also okay. Okay, now scalar matrix is such a diagonal matrix where each and every diagonal elements has to be same. Whatever it is, it has to be same. So far we have discussed row matrix, one row, okay, whatever be the column matrix, one column, whatever be the number of row. Then we have discussed square matrix, clear to you, number of row, number of column
Yes.
has to be same.
Yeah.
Then we
Are
have
equal.
diagonal matrix, right?
Mm-hmm. Only no only all non-diagonal elements are 0. Okay,
Yeah,
next.
all non-diagonal elements are 0. Okay, non-diagonal elements has to be 0. Whatever is diagonal element, that those are 0, not 0, it's completely fine. Now scalar matrix is such a matrix where the diagonal elements, okay, its scalar matrix is basically a diagonal matrix, Ibrahim. Okay, here
Yeah.
diagonal elements has to be same. Okay, all the diagonal elements will be same. Now identity matrix, as the name says, identity. Okay, here all the elements, it's a square matrix. So 2 by 2, or maybe 3 by 3, or maybe 1 by 1.
Mm-hmm.
Okay, here each, like the diagonal elements has to be 1. So if I'm writing only
Okay.
1 over here, that is fine. Here all the non-diagonal elements are 0, and the diagonal element has to be 1. This is identity
Mm-hmm.
matrix of order 2 by 2. Got it?
Yeah.
Okay, if 3 by 3 I will write, everything is 0. Non-diagonal elements are 0. So 1, 2, 3. These are diagonal element except that everything is 0. Everything is 0. Okay, and the diagonal element has to be 1. Identity, as the name says, identity. Okay, the diagonal elements has to be 1. Got it?
Yeah.
Okay. Now, zero matrix is such a matrix where it can be, okay, it can be rectangular matrix, as you can see, 3 by 2, 4 by 3, whatever. Just only condition for zero matrix, we call it null matrix as well. Zero matrix or null matrix is such a matrix where each and every element is zero. Whatever is the order, fine. Whatever is the
Mm-hmm.
order, fine. Just each and every element needs to be zero. Got it?
Okay. Yeah.
Okay, now equality of matrix. If we are having two matrix equal, then we can say the element A11 over here. Basically, one thing you must note, when we are talking about equality of matrix, both the matrix must have same order. Okay, so as you
Mm-hmm.
can see, it is 1, 2, 3. Okay, 1, 2, 3.
Yeah.
So 3 by 3 matrix, and this is also
3
3
by
by 3 matrix.
more than 3 by 3.
So
Yeah.
when we are talking about equality of matrix, order has to be same, strictly needs to be same. Then only you
Mm-hmm.
will be comparing the first A11 over here with the A11 over there. You will be
Okay.
comparing A12 over here with A12 over there. Okay, you will be
Okay.
comparing A13 over here with A13 over there. Okay, and
Yeah.
after doing the comparison, you will be able to find the value A, B, C, X, Y, Z. Okay, you will be getting so many
Okay.
equations from here, and we need to solve all those equations to get the unknowns. So let's do it.
X is -3. Yeah.
X is -3. Yeah, perfect.
And then Z will be Z plus 4 is equal to 6. That is equal to 2.
Perfect.
Z is 2. Then Y will do later. What else we can do? A minus 1. Okay. A minus 1 equals to -3. A is equal to A is -2.
Okay.
Y is -5. Okay. Y is -5.
Yeah.
Y is equal to -5. And what else? Okay. B minus 3 is equal to B plus -7. B is equal to -7.
Okay. And C?
C is 2. C plus 2 is equal to C equals to -1.
Okay. Perfect. Okay. So this is the concept of equality of matrix, and this is how the question will be given to you, that find the value of the,
Mm-hmm.
just by using the concept of equality of matrix.
Okay.
Let's do the next one.
Find the value of X, Y, and Z. Okay. X plus X plus Z equals to 5. Y plus Z equals to 7. X plus Z, okay. X plus Z is equal to 9. 5 plus Y is 4.
Okay.
Y is 4, we can say that. And then 4 plus Z. 4 plus Z is equal to 7. Z is 3. Yeah, Z is 3. That will be 3, and X plus 3 equals to 5 is equal to 2. X will be 2.
So you have created the equations from here, right? Have you
No,
taken
no,
the,
one second, one second, one second. 5, 6, 7, 7, 8, 9, 10. No. Yeah, yeah, yeah. X plus Z will be 5. 5 plus Y equals to 9.
yeah,
Y is
perfect.
equal to 4. Yeah,
Yeah,
4.
correct. This one
Five.
also you will be able to do, right, Ibrahim?
Yeah, yeah. Example
Wait,
of a Okay.
Few more things over here. Just a moment. So in type of matrix, there are two more types. Okay, that is
Mm.
triangular matrix, upper triangular matrix, lower triangular matrix. Okay, this triangular matrix you will not encounter question in your NCRT, but these types are there. You will be getting such questions in competitive exam. So I must add over here, triangular matrix is such a matrix. Triangular matrix, upper triangular, lower triangular. So upper triangular matrix, of course, it will be a square matrix first, and it will
Mm.
the suppose we are having the diagonal element as a 1, 2, 3. Here we'll be having suppose 5, here 8, here 9, here 0, 0, 0. Yeah. So upper triangular matrix is such a matrix where you will be okay, the diagonal matrix. Okay, on the above you will be able to see the numbers, the elements. This is the diagonal matrix. Here the elements are there.
Mhm.
Okay. Below this diagonal, can you see the element
Everything is zero.
0, 0, 0? So
Yeah.
basically in definition, it will be written like this, that when I is bigger than z, okay, those aij are 0. Let me write the structure. Here you will be having a11, here a12, here a13. Okay, here a21, 22, 23. Here
Mm-hmm.
A31, here A32, here A33. Definition says that upper triangular matrix must contain all those ai's is 0 where I is bigger than z. So let's see where exactly we are having I bigger than z. Can you see I bigger than z? Can you see I bigger than z? Can you see I bigger than z?
Mm-hmm.
Okay, just that. As the name suggests, upper triangular, when these element I will make 0, 0, 0, 0. Can you see it is taking the shape of
Yeah.
upper triangular?
Yeah. Yeah.
Okay. And the downward, the lower triangular matrix is just the reverse case of this, where I is the smaller than z, all those i's will be 0. So you can understand that here, if I will again take, if again I will take this structure, A11, A12, A13, okay, A21, 22, 23, A31, A32, A33.
Eight, three, three. Mm-hmm.
Wherever I is smaller than Z, okay, I is smaller than J, I is smaller than Z,
Yeah.
I is smaller than Z. Can you see it? Anything else where
Yeah.
I is smaller than Z, Ibrahim?
No. No. No.
0, 0, 0. Okay, and it has taken the shape of triangle. This is called lower triangular matrix. Got it?
Yeah. Okay. Okay. So in
So,
upper triangle, I will be bigger than J, and in lower triangle, I will be smaller than J. That's it.
and all those elements are has to be 0.
Okay.
Okay, that's called upper triangular. And in lower triangular, when I is smaller than z, all those elements has to be 0. That's called lower triangular matrix. Now the next example, we have to give, okay, you will be giving example of a row matrix, which is also a column matrix. Please give one example.
1 second. Yeah. I'll just write.
Yeah.
Okay. Oh yeah, that. Uh, a row matrix is also a column matrix. Matrix bracket one, just like any number one.
Perfect. Okay. Next, a
A
diagonal matrix
diagonal.
is not a scalar.
We draw it like 2 by 2 matrix. We can draw 2 by 2 matrix, and we can put 1 and 2 in one diagonal, 0, 0 in the other diagonal.
Like this.
No, in one diagonal. Diagonal.
Now you are saying
Yeah.
like this.
Mm-hmm.
Yeah. Okay. It is not a scalar, but it is diagonal. Triangular matrix. You have to give example of upward triangular matrix and downward triangular matrix.
Okay, so with the 3 by 3 matrix,
Hmm.
both sides. Yeah. And then for upward, for upper triangle, what we'll do? 1, 5, 7, random numbers you have given. 1, 5, 7,
Hmm.
0, 6, 2,
Hmm.
and 0, 0, 3.
Perfect. Okay. For downward triangle or for
Downward triangle will be just a second. Hold on. Look. And because I also need to draw, yeah, to visualize. 0, 0, 0. Okay. 1, 0, 0, 5, 7, 0,
perfect.
and 6, 2, 3. Example.
Perfect. Okay.
Yeah.
So these are the examples of upper triangular matrix
Mm-hmm.
and lower triangular matrix. Now
Yeah.
operations on matrix. Okay, operations. Whenever you have learned anything in maths, first you have learned about numbers, so you also learned at the same time how to add these numbers, how to do the subtraction, how to do multiplication, division. Then the same you learned about decimals, the fractions. Here also we'll be discussing about how to do operations on these matrices. Okay,
Mm-hmm.
operations in mathematics, whenever this term will be there, we will think that operation means addition, subtraction, multiplication, division. Okay, so
Uh-huh.
basically here we will be discussing at first the addition of two matrices. If we are
Mm.
having two matrices like this, then if we have to add these two matrices, it is really simple. We just need to add the, like, first thing first, both must have same order.
Uh-huh.
Okay, then only you will be getting the term. Okay, a11 you will be able to add with a11. Okay,
Yeah.
so you will be able to add with a12. So basically
Mm-hmm.
element by element we just need to add them, that's it. So 80 plus 90, 170. Okay, 60 plus 50, 1110, 110. Making sense?
Yeah.
Okay, 70. Okay, yeah, 75,
Yeah.
70, 75, 70,
145.
65, 55,
Yeah.
90 with 75 will be adding, and 85
85 and 75.
with
Okay.
75 will be adding. So basically both, the condition is when the orders are not same, we will say a plus b is not defined. Okay, if
Okay.
anytime anyone will say, or the question says that add these two matrices, suppose I am writing 2 1 3 4 5 2 added with 3 2 1 3. Okay, here clearly we can see the order of these two matrices are not same, right? Addition is not possible. A plus b
Not
is,
possible. Okay. Yeah.
okay, and it makes sense as well. We must have this a11 added with a11, a12 added with a12, but what will be adding with 3? Okay, it
Nothing.
makes
It's
sense as
nothing.
well.
Yeah.
Okay, addition is
Yeah.
not possible. Multiplication of a
Mm-hmm.
matrix by a scalar. Scalar, when we are saying, okay, you can add over here a scalar or a function. Okay, same way we will be doing the multiplication. Even if it is just a scalar, that means just a number. Okay, 2, 3, 4, 5, 6, or maybe k. Okay, or maybe
Mm-hmm.
a function. We will be doing the same process. The process is, if you are having a matrix, that is, suppose you are having 1, 2, 3, 4, 5, 6, and you need to multiply a matrix. A is given over here. This is A, and you are multiplying it by a scalar, that is 2.
Mm-hmm.
So basically, we'll be multiplying each and every element by 2. Each and every element. So 1 will, you will multiply
Okay.
with, this 2. Okay, 2 you will multiply with 2, this is 4. 3 you will multiply with 2, 4 you will multiply with 2, 5 you will multiply with 2, and 6 you will multiply with 2. Got it?
Okay. Yeah.
Okay, negative of a matrix. Suppose you are having a matrix A, the same matrix I am taking 1, 2, 3, 4, 5, 6. Negative of this A will be minus A. Okay, when we have to
Uh-huh.
calculate minus a, we will be, yes, are you asking anything?
No, 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 no.
Okay, so suppose we are having a matrix A. If we need to take, if we need to take out negative A, okay, so we will take it like a scalar multiplication. We will say that minus 1 multiplied with the given matrix. And then the way you have done, okay, we have done the multiplication of a scalar in the previous example, same way we will be doing the multiplication over here. Getting it?
Okay. Yeah.
Okay.
So -1, -2, -3, -4, -5, -6. Okay.
Yeah. Okay, now difference of matrices. So whenever we are having two matrices, for example, if we are having a matrix, suppose 2, 5, 8, 7, 3, 4. Okay, if we have to find the difference with another matrix 5, 4, 2, 8, 9, 7, again just like the addition here, in difference also the order needs to be same. Okay, order
Okay.
of both the matrix needs to be same. So the first one is 2 by 3 matrix, second one is also 2
Mm-hmm.
by 3 matrix, then only we are proceeding with the operation, that is difference between these two matrix. In matrix we say the difference is nothing, just here we can take the addition, and this minus 1 we can do the multiplication in this, the second matrix. Getting it?
Yeah.
And the way we have added both the matrix, same way we can add both of them then. Okay, addition of this
Mm-hmm.
number 2 with the other number, that is negative 5. Getting it?
Okay. So so what will get? 2 minus 5, that's -3.
Yeah.
-3, 1, 6, like that will get.
Yeah, that way. Okay,
Okay.
actually the definition says that we don't know how to do difference of two matrices, but we can take the help of addition and scalar multiplication, and we are doing so. But while solving
Okay.
the question quickly, we will be writing from here directly. We will be writing 2 minus 5. Okay, 7 minus 8
Okay.
directly we'll be writing. From where it came we understand. Okay, actually this
Mm-hmm.
matrix basically is used in programming language and everything. That's why the computer
Okay.
understand it like this only, that we don't know, okay, the program don't know how to do the difference, but it will give you the answer.
Mm-hmm.
How? By taking the addition. Okay,
Yeah.
now the next one, next example. If the
If
diagonal
A is
matrix is
equal to
given and the diagonal matrix is given, again find a plus b and find 3a plus 4b.
-, 'A plus B will be 3, 0, 0, 0, plus 3, -2, 0, 0, 0, 1. Yeah.
Okay, and 3a
Now
plus
3,
3a plus 4b.
3A will be, yeah.
4b.
Okay. 3. 11, 0, 0, 0, 3, 9, 0, and 0, 0, 2.
Okay,
Yeah.
so can you see, Ibrahim, here the calculation? This negative 2 will be there.
Mm-hmm. Yeah. Oh, yeah, it's supposed to be -6, yeah.
Wait,
So like the second
talking about a
row,
plus
it
b.
will give us 6.
Wait, I'm talking about a plus b.
Oh, A plus B. Okay. Oh, that's correct.
Just take a pause and observe it carefully.
A plus B. 1 plus 2 is 3, correct. -1 plus 3. 3 minus 1, that's 2. I said positive 2. Okay, yeah, positive 2.
Okay, it will be positive. So if I will write
Uh,
Ibrahim, the diagonal of this plus diagonal of that is nothing but diagonal 3, -2, 1, right?
mm-hmm.
Which we will be getting directly as well if you will observe.
Yeah,
1,
1 plus 2, -1 plus 3, and 2 plus 2 minus 1. Yeah,
okay? So
yeah.
if you are giving any other exam here, you need to show the steps. If you are giving any other exam, you can write it directly, right? Okay. Now 3a
Okay.
plus will be that also. Let me check first. So we are having 3, -3, 6. And here we are having 8, 12, and -4. So yeah, 8, 9, 10, 11, -3 plus 12. Yeah. And 6 minus 4. Perfect. This is the next question. As I said while explaining that how to do the multiplication by a scalar. Here you can see
Uh-huh.
we don't have a scalar. We have a function. Can you
Function.
do the multiplication like a scalar? Yes. Then we need to add them. Okay. And
Okay.
then here
Function.
we will be getting the final answer as well, because here also simplification, okay, the property of this trigonometric functions, that is possible.
What do we get? Cos square theta plus sin square theta. That's 1.
Mm,
And sin theta cos theta minus sin theta cos theta. That's 0.
mm,
So 1, 0. And then sin theta cos theta minus sin theta cos theta plus sin theta cos theta is 0.
mm.
Cos square theta plus sin square theta is 1. Diagonal matrix.
This is identity matrix I.
Yeah.
Okay.
Identity, diagonal, square, and
Yeah.
what else? That's yeah,
Scalar.
yeah, scalar.
Okay. Yes. Next. This type of question you have done in the previous class. Okay. That time
With
we were
sets we
having
did, I guess.
equation. Here what we can do, we can add these two matrices. Okay. After adding them, how will be adding? This side will be adding with this side, and that side will be adding with that side. Okay, so let's do it together.
Okay.
So basically we can directly add. Okay, x
Yeah,
plus
x plus y plus x minus y.
x minus y is equals to this matrix added with that matrix.
Uh,
Y gone, we are getting twice x is equals to, we can write the added form
yeah. 10, 0, 2, 8.
to 8. Okay, then we can say that x is the way we deal with basic equation. Same way you can write here, you will be having 1 by 2. Okay, this matrix says that basically what we are doing, we are dividing both side by,
Multiply
we are
by 2, yeah.
actually we are dividing both side by 2. Okay.
Oh, okay,
Okay,
okay, okay, okay. Yeah.
and then we are getting x, but We understand. Okay, we can write directly as well.
X equals to, okay, yeah. X will be
Now
5,
this is, we can deal,
0.
we can treat
Yeah,
it like a scalar multiplication. So at the
okay,
end, our x will be 10 by 2. That means 5.
5,
4 by 2,
0,
that means 0. 2 by 2, that is 1. 8
1
by 2, that is 4.
by 2, that is 4.
Clear?
Yes, and then Y. And Y. Okay,
And this x we can substitute over here.
yeah, yeah, the first equation we can substitute X.
Yeah,
Plus
5,
5.
1, 0, 4 added with y is equals to 7, 0, 2, 5. Y is directly we'll be writing, okay, this to the other side with negative sign. And as I said, that directly you can write the subtracted form, okay, the answer.
Yeah,
So the
7
way
minus
you
5, that is,
basic equation, similarly we are dealing over here. Okay,
okay, yeah.
next. Properties of matrix addition. Matrix addition, if you will take so many example, and if you will check, you will find that when you are doing the addition of a plus b, or you are doing the multiplication of b plus a, let's check it. Suppose our a, there is a matrix that is 2 5 3 4, and b is another matrix that is 1 2 3 4. If we will add a and b directly, I am writing the added form, that will be 3 5 6 7 3 3 6 4 4 8, right, Ibrahim?
Mm-hmm. Yeah,
If you
correct.
will find b plus a, first you are writing b, then you are writing a. What are you going to get? Are you going to get the same? Yes or no?
Yes, yes, same equal.
Okay, so matrix addition is commutative. A plus B and B plus A always will give the same answer because basically we are adding the elements over here with the elements over here.
Mm-hmm.
That's what the first property says, that matrix addition is commutative. Okay, it follows commutative law. Okay, if A will commute at the place of B and B will commute at the place of A and add it together, it will not make any difference. The result
Okay.
to be same. Associative law also it will follow, that if you are having two matrix, suppose you are having three matrix A, B, C. If you are adding A and B at first, and the result whatever you are getting, that you are adding with C. So whatever result you will be getting, that result will be same as when you will be adding B and C at first, and then you will be adding A. This both the result will be exactly same, because again we are doing
Uh-huh.
the addition of element, the a11 with a11 with a11, that's it. Getting it? So
Yeah.
matrix will follow the commutative law, associative law as well. Okay, now the next one is existence of additive identity. Existence of additive identity. Additive identity means, you can remember it like this, that what should be added with a matrix A, so that the identity of A is not getting changed. A must be added with any matrix, but the identity is
Mm-hmm. Zero matrix.
to zero. And this zero matrix and null matrix, we also represent it by O. So whenever O will be written, no, please understand that it is representing null matrix. Getting it?
Okay. Yeah.
So zero is the additive identity of any matrix. Existence of
Mm-hmm.
additive inverse. Okay, additive inverse means, suppose you are having a matrix A, what should be added with that? Okay, so that the result is zero. What should be added with A so that the result is zero? So
Minus
negative.
A.
Okay, this
Yeah.
is, in question will be given the matrix in MCQ question will be like this: the given matrix A, find the additive inverse of it.
Mm-hmm.
Okay, or what is the additive identity for the given matrix? So this is how
Okay.
MCQ question can be asked. Now property of a scalar. So basically you already understand distributive property. Okay, if we are
Yeah.
having a in general, if suppose we are not talking about matrix, we are talking about just a bracket is there and a number or maybe a variable is sitting outside. So how we apply distributive property? We multiply it with the first term, we multiply it with the second term, right?
Mm-hmm.
Similarly here also, if you are having a scalar k and if you are having matrix A and matrix B, so basically whatever result you will be getting from here, you are adding A and B at first and then you are multiplying the scalar with each and every element.
Yeah.
Whatever result you are obtaining from here, okay, you will find that that result and this result is exactly same when you are
Mm-hmm.
multiplying the scalar first and then you are adding them. Both are exactly same.
Okay.
So the first property is that only, that this wait, not that one, this is same as this, which makes sense, right?
Uh-huh.
When we are having a scalar k and l and that we are multiplying with a, that is same as ka plus la. Getting it?
Yeah, okay. Yeah, yeah.
Now when we are having just this one we have already discussed, this one, okay, this is, these are just the proofs, that's it. Okay, so these are the property which you need to keep in mind. The way you were applying
Uh,
distributive property, same way you will be dealing with the matrix. Okay, now
mm-hmm.
suppose we are having a matrix A. Okay, 1 2 3, 3 by 2 matrix over here we are having, 3 by 2 matrix over here we are having, right Ibrahim?
Yeah.
Okay, find the matrix X such that this condition is given over here. Okay, a condition, a relation is given over here. With the help of this one, we need to find X from here.
Okay.
So actually how the programming goes, let me show it to you a little bit. You can do it directly. So if you have to find 2x plus 3x is equals to 5b. Okay, actually when we have to find x from here, what exactly goes behind the scene, let me show you. So at first we will try removing this 2a from here, right?
Yeah. So we'll take it RHS.
We will take it to other side, but
Yeah.
programming is like this, that 2a plus 3x is there, so here we will do subtraction of 2a and here we will do the same subtraction because equality sign needs to be maintained, right? Whatever is
Okay.
subtracted
Yeah.
here, the same thing is subtracted here. Getting it?
Okay. Yeah.
Now
Yeah.
we will say that since matrix addition, this can be written as plus of minus 2a like this, and this is,
Mm-hmm.
we will say since matrix addition is commutative, so even though this will go over here and this will come over here, it's the same thing. Getting it? So
Yeah.
this is how the computer will work on matrix, that
Mm-hmm.
minus 2a plus 3x, and here we will be having just 3x is equals to 5b minus 2a. Now both side
Yeah.
it will divide by 3. Okay, just
Yeah.
to
We'll divide by five.
isolate this x. Isolating x means keeping x on one side. Okay, so 3 over here, 3 over here, so basically x we will be getting 1 by 3, 5b minus 2a.
Minus two.
This is,
Yeah.
this things will go on behind the scene, and basically we can write directly by using our older concept that okay, this is just a, in the form of equation, we can take it as a 3x
Mm-hmm.
equals to 5b minus 2a and x is 1 by 3, 5b minus 2a. We can do it directly.
Yeah.
Okay,
And then we can easily do.
and
Yeah.
easily we can find the value of x. Please do it.
5b minus 2. Yeah. Okay. 1 by 3 times 5b. So 10 minus 10. So and then we'll get minus 2 minus 10 by 3, 12 divided by 3, that's 4, 14 by 3, minus 19, oh wait, no, minus 31 by 3, and minus 7 by 3.
Okay.
Yeah.
This is how we need to take out the value. Okay. Now the next one is also exactly like that. Okay. A plus given matrix is equals to another given matrix. We can find A directly by taking this matrix minus that matrix, right?
Mm-hmm. Yeah.
Next one.
Yeah.
Find the value of xy from the given equation. So this is by
Okay.
using the concept of equality of matrix, you can find the value of x and y, right? First you will be doing the scalar multiplication over here. Okay, then you will be
Mm-hmm.
adding it with the another given matrix, then you will be comparing the a11 with a11 over
Yeah.
with a22 with
And
a22.
A2,
Okay,
A2,
like that.
yeah, okay.
So so far we have discussed so far we have discussed types of matrix. We have also discussed all the types, the operations on matrix addition, okay, how to deal with subtraction, then scalar multiplication, what are the properties of scalar multiplication, what are the properties of this addition of matrix. It is commutative. Keep it in mind, in MCQ question it can ask that is it commutative or
Mm-hmm.
not. Why you need to keep in mind? Because the multiplication is not commutative. Okay, the matrix
Ah,
multiplication of A and A are not same always. Okay, in our real
mm-hmm.
world with real number, yeah, if you will take any two number, you multiply it this way or you multiply it that way, the result is same. But with matrix it doesn't works like that. That's why, okay, you need to keep in mind that addition is commutative. Okay, a plus b added and b plus a both added together is same. Okay, now we will be starting the discussion of multiplication of matrix.
Mm-hmm.
Okay, so I'm just showing this one over here to you. This is really important with 3 by 3 matrix, with mostly 3 by 3 matrix. Okay, we will be seeing the multiplication and everything. I'm just little bit, just a glimpse of that, I'm just showing it today, or maybe I'll be taking this one in the next class freshly. Okay,
Okay, yeah,
to
we
start
can do this in the next class.
with
Because I have one small question from another chapter. Can I ask?
yeah, yeah, sure, please do ask.
Yes. No, 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 you take this. The question is, examine the differentiability of f of x for this function at x equals to 1 and x equals to 2. It's a worksheet question. So like our teacher gave it to me.
Yeah, what is
Can I write it on the screen
yeah,
if I can?
you are able to
I don't know
annotate.
because my
Otherwise,
mouse
you
isn't
can,
working.
yeah.
Okay, let's just see.
Otherwise, if here you are not able to annotate, then you can send the question to our team. They will forward it to me. The number
Okay,
you
o-
get the link of.
okay, Devin. Okay,
Okay, I'm asking.
okay, this is the question, so I'll forward it.
Hmm.
Okay, Mama.
Hi, ma'am. Can I take your 1 minute?
Yeah, sure, please.
Yeah. How are you, by the way?
Yeah, I'm good. How are you?
Yeah, fine. Thank you. Actually, fastings are going on now, so I'm just busy in cooking.
Yeah.
Actually, he decided to go for NEET. This year he decided. So, what do you think for maths? What to do? Because he took PCMB.
Hmm.
So, for maths, can I go for the like only for CBSE or with competitive?
I can see he's doing really well since he wanted to go for NEET.
Because
So,
in NEET, maths is not there,
yeah,
but he took PCMB.
yeah. So, if he want to go for NEET, I would suggest he must keep his focus on biology mainly.
Okay.
And for maths, he can just do CBSE, just parallel
CBSE, na?
CBSE.
Okay, okay. Because he's supposed to take for whole subject in Learnivio only.
Hmm.
So in the beginning for maths, chemistry, and he will see like for 1 month. If he's adjust, then he will continue with bio and physics also.
Okay.
So that's why I'm asking you, okay, for maths, only CBSE or with NCERT is enough, right?
Yeah, with this only this much is enough, because he needs to be focused that on one,
Yeah,
like keep the focus
exactly,
on one thing, that is really important. Okay, so here
exactly.
he can do CBSE, and there.
Because he already missed his 1 year, 11th. Now he decided, because since last year, Mama, I don't know either engineering or medicine. But now he decided he want to go for medicine. But in anywhere now, it is compulsory for Indian student to appear in for NEET.
I can see his maths. Okay, it's really good. He understands